I'm not going to waste your time. This video is a complete, focused, and practical breakdown of everything you actually need to know about Google Gemini, why Google built it, what makes it fundamentally different from previous AI systems, how its multimodal capabilities work in real-world scenarios, and why it represents such an important shift in the future of artificial intelligence, because from the very beginning, Google has always described its mission as a timeless one, organizing the world's information and making it universally accessible and useful. But as information has continued to grow in scale, complexity, and variety, that mission has become significantly more difficult, and Google knew that traditional software alone would never be enough to solve this problem, which is why artificial intelligence has always been central to their long-term vision, especially the idea that AI could become one of the most beneficial and consequential technologies for humanity. And this belief is what ultimately led to the creation of Gemini, a model designed around the idea that humans experience the world through multiple senses and multiple formats at the same time, including text, images, audio, video, and code, meaning that if AI is truly going to be useful, it needs to understand and reason across all of these modalities together rather than treating them as separate problems. And this is exactly why Google announced the beginning of what it calls the Gemini era, positioning it as the first real step toward a truly universal AI model. Because unlike traditional multimodal systems that are built by loosely connecting text-only, vision-only, or audio-only models at a later stage, Gemini is multimodal from the ground up, which allows it to seamlessly move between different types of input and output and deliver responses that are more contextually aware, more natural, and more human-like, enabling it to understand the world in a way that is much closer to how people do, by absorbing and reasoning over text, images, audio, video, and code within a single unified system. And this is why Gemini has become Google's largest and most capable model, with training results showing that as it reached maturity, it began outperforming every other existing model on many of the most important benchmarks, including tests across 50 different subject areas where its performance matched or exceeded expert-level humans, something that is extremely rare for a foundational technology that can simultaneously improve products across an entire ecosystem. And to ensure this power could be used everywhere, Google created a full family of Gemini models that can operate across different environments, from massive data centers down to mobile devices, with Gemini Ultra serving as the most powerful and capable model for highly complex tasks, Gemini Pro offering strong performance across a broad range of everyday use cases, and Gemini Nano focusing on efficiency for on-device applications, all while giving developers and enterprise users flexible foundational building blocks that they can further refine and adapt in creative ways. And at the same time, Google has emphasized that as AI systems become more capable, they also introduce new challenges around safety and responsibility, especially in multimodal situations where individual inputs like text or images might be harmless on their own, but could become problematic when combined, which is why Gemini was built with safety considerations integrated from the very beginning through proactive policy design, extensive testing, and the use of filters and classifiers to mitigate known risks, continuing Google DeepMind's long-standing tradition of leading foundational AI breakthroughs while remaining committed to responsible deployment. And when you actually see Gemini in action, its multimodal intelligence becomes immediately clear through live demonstrations where it can visually identify drawings, objects, colors, gestures, and physical actions, reason about what it is seeing, maintain conversational context, translate words into other languages, explain pronunciation details such as tones in Mandarin, invent games using emojis, and even understand physical interactions like sleight of hand tricks or object movement in real time, showing that it is not simply recognizing patterns but actively reasoning across modalities. And this capability becomes even more compelling when examining the benchmark data, where Gemini Ultra was directly compared with GPT-4 and achieved higher scores in 7 out of 8 major categories, including general knowledge, reasoning, mathematics, and coding, with particularly strong performance on math problem solving, code generation, and natural language to code benchmarks. And when moving into multimodal benchmarks, Gemini Ultra surpassed GPT-4 with vision across all image understanding tasks, exceeded previous video understanding systems when compared with earlier DeepMind models, and even demonstrated stronger performance in audio tasks than established speech models, reinforcing the idea that Gemini is not just competitive, but genuinely state-of-the-art across modalities and beyond benchmarks. Gemini's reasoning abilities allow it to move far beyond traditional chat interfaces by dynamically deciding when text alone is insufficient and generating fully customized visual and interactive user experiences on the fly, such as when helping plan a child's birthday party by identifying ambiguity, asking clarifying questions, constructing a detailed internal plan similar to a product requirements document, designing an interface optimized for exploration and detail, writing the necessary code, and populating it with relevant content and images, all without any manual programming. And the same reasoning power applies to education, where Gemini can analyze photos of handwritten homework, identify which answers are correct or incorrect, explain mistakes step by step, adapt explanations based on the learner's needs, and generate personalized practice problems, as well as to scientific research where it can read hundreds of thousands of academic papers, filter for relevance, extract structured data with annotations showing exactly where information was found, update data sets, regenerate figures by producing code from visual inputs, and complete workflows that would normally take humans weeks or months in a matter of minutes. And these capabilities naturally extend to any domain that relies on large volumes of complex information, including law, finance, and engineering, especially when combined with Gemini's long context window of over 32,000 tokens, which allows it to retain and accurately retrieve information from extremely long documents with very high accuracy, even when key details are buried deep within the text, representing a major leap beyond models with shorter context limits. And Gemini's multimodal intelligence becomes even more evident in video understanding, where it can analyze motion, technique, and body positioning in sports footage, explain what is going wrong, and suggest improvements based entirely on visual evidence, demonstrating that its reasoning is grounded in what it actually sees rather than generic advice. And according to Google DeepMind, this is still only the beginning, as future versions of Gemini are already being explored for integration with robotics, including touch and tactile feedback, which would allow AI systems not only to understand the world, but to physically interact with it, combined with ongoing research into reinforcement learning, planning, and search techniques inspired by earlier breakthroughs like AlphaGo, all of which points to rapid advancements and entirely new innovations in upcoming releases, making it clear that Gemini is not just another language model, but a foundational shift toward AI systems that are more capable, more integrated, and more useful across nearly every domain, with the ultimate goal of expanding access to knowledge and making artificial intelligence genuinely helpful for people everywhere in the world.